Okay, page 3. We're going to look at how to simplify these, but these are really easy. What's a simplified expression for cosecant tangent? So what do you guys think we should do first? So change them to 1 over sine cosine. Yeah, and cosine. Just change everything to sine cosine. So 1 over sine times sine over cosine. All right, at this point, it's very simple. You can probably see what's going to happen. Sine's going to cancel. So you're left with 1 over cosine. And then 1 over cosine is what? Secant. Okay, so then you're done. Okay, so simplifying is actually really easy. You will almost always end up with a number or a trig function. So just a one simple trig function. So let's have you guys try this next one. Okay, so this example, the answer is cosecant theta. Okay, I want everyone to go ahead and try the next two. Now, if you are not really sure where you're supposed to get to, I'm going to tell you what answer you're supposed to get. This one, you're supposed to get 1. And this one, you're also supposed to get 1. 2 is a lot harder because this is just like an algebra nightmare because it has a lot of fractions. But just try it anyways. You got to review the stuff we learned in Chapter 8 on simplifying complex fraction. Okay, number 1 is pretty simple, so I'm going to trust that you can get this. Number 2, let's go over this. Because this is a very complicated algebra, so when you get to complicated algebra like this, which is going to be a lot of next year, and definitely calculus, you got to just know how to do it without making any mistake. So I'm going to show you kind of how you should approach it with, basically every single step written out. Don't skip any step, and then just kind of logically go through it. Okay, what should we do first? Oh, okay, yeah, so change everything to sine and cosine. Okay, so that is 1 over sine over, so when you write a fraction bar, the long one, please make it very clear which one is the long one. Sine does not change. Cosine does not change, and then cotangent becomes cosine over sine. All right, at this point it looks very complicated, but just continue simplifying. Don't write a lot of different steps. Don't separate your numerator, denominator. Just write it all in one go, okay? All right, what's next? Multiply the cosines together. Okay, 1 over sine over sine theta plus cosine square theta over sine theta. All right, what's next? There are 2 ways to do this after this point, but you can do whatever is the most comfortable for you, as long as you do not separate the numerator and denominator in 2 separate things and then combine. Okay, right now it might be easy for you. Later on, you will not figure out what you did wrong at all. Okay, so don't do that. Just write it all together. Okay, what's next? Same denominator, perfect. No. Okay, sine. You may want to write this if you think you're going to get confused, but once you get used to it, next year I would say almost nobody writes it out. Okay, so you should always keep track of which fraction bar is the longest one, because you don't want to flip the wrong fraction, okay? All right, what's next?
Simplify the top, it's 1 over sine.
Oh, simplify this part?
Yeah.
Okay, so 1 over sine over 1 over sine. And then at this point, you can see that it's just 1. Same thing over the same thing is always 1. So if you keep it very consistent throughout, you should be able to get the answer really quickly. If you start separating and you get the wrong answer, it's almost impossible to figure out what you did wrong. Then you have to start again, and that's not good. All right, the last few is just practice, but I'm gonna let you do one at a time. That way, if you get stuck, at least I can help you. Okay, so number 3. So everyone try number 3. When you're done, let me know. actually. Maybe I should help you on this one. Okay, so number 3. What you want to do when you see these kind of identities is you want to look at your destination, the right-hand side, and then ask yourself, what is the relationship? Can I see a pattern? That way it can help me figure out what I should do. So number 3, what do you guys notice is interesting or similar about the left-hand side and the right-hand side? Cosine, yep, say that again. Cosine, but cosine is a little bit different in that one is in the denominator, one's in the numerator, right? Okay, what else do you notice that's kind of interesting? 1 minus sine, 1 plus sine. Okay, so that looks very interesting, like they're kind of related. Okay, now let's think about 1 minus sine and 1 plus sine. What does that kind of remind you of? 1 minus sine, 1 plus sine. Some kind of identity, but which one? Huh? Squared. Okay, so let's think about this. This is kind of 1 minus sine, 1 plus sine. It's kind of like a minus b and a plus b, right? What does that remind you of? Hopefully remind me. So, not so. Difference of squares. Okay, so to get there, we need to use difference of squares somehow, right? So yes, it's probably going to be this, 1 minus sine squared. So the question is, how do I get there? Okay, how do I get there? Cosine squared. Okay, I need a cosine squared. So number 3 on the left, how do I get this cosine squared? Yes, multiply by cosine theta over cosine theta. Okay, so this is where, this is kind of the trick. You have to kind of memorize, okay, when I see something like this, where the numerator denominator switches, one of them is a 1 plus, one of them is a 1 minus. This is the trick you use. You gotta somehow get to a squared minus b squared. Okay, so this becomes cosine times 1 minus sine theta. Please make sure you put that thing in parentheses, and then over cosine squared. Cosine squared becomes 1 minus sine squared. Can you, yeah. Any questions up to this point? It's a tricky one. You cannot just cross it out. You have to cross it out by factoring first. So, because this one's a square, this one doesn't have a square. You can't just cross it out. Yeah.
Oh, why did you put 1 minus sine on the bottom again?
Okay, the reason being there is a 1 plus sign, and then somehow I need to change from 1 minus to 1 plus. And then I can think that 1 minus and 1 plus kind of reminds me of a minus b, a plus b. So somehow I'm going to have to get to a 1 minus sine squared. Because 1 minus sine times 1 plus sine is 1 minus sine squared. So
what do you do with the cosine? Just kick it off?
Cosine squared is 1 minus sine squared.
Oh, okay. Thank you.
All right, so at this point, 1 minus sine squared becomes 1 minus sine times 1 plus sine. Okay, a squared minus b squared is a minus b times a plus b. Yeah, didn't know you can apply this? Yes, you have to apply it. You're going to see things like cosine squared minus sine squared. You're going to have to factor. So anytime something remotely looks like a squared minus b squared, you got to just notice. I'm sure you guys would not have any problems if I just gave it to you in x and y. You would see these things. But then now we're in sine, cosine, so you're not used to it. All right, this cancels. Cosine over 1 plus sine. So that is done. That's a complicated one. So at this point, so I'm kind of giving you some tricks that you can put in your bag. So you're now like, okay, Okay, this is another trick I learned. Whenever I see something like this, 1 plus, 1 minus, I'm going to think difference of squares. All right. The next two should be pretty easy. I'm going to just let you do it. Number 4. So go ahead and try it. Let me know when you're done.